Hello, everybody, and welcome to one of my favorite versions of the OpenShift Commons briefing. That's when we run down what's in the latest release of OpenShift. And I'm really pleased to have Scott McCarty, who's wrestled up a whole bunch of the other PM product management team from Red Hat to give you a not quite high level, not totally deep level, deep dive on what's in OpenShift, but we've got a lot of the PMs here. Format today will be Scott's going to kick it off. Each of the PMs will take their section that they're in charge of. We'll have Q&A at the end if there's time. So what I would say is ask questions in the chat while people are talking, because there's plenty of people on to answer them, and we'll have open up the mics at the end. So with that, take it away there, Scott.
Hey, thanks, Diane. Yeah, thanks for having us. I rustled up. There's about 5 of us, I think, from the PM team, product management team on. And we're going to just do, I'd say like a 201 level, the deepest dive we can do in the amount of time we have. So I'll just dig right in. Oh, one other thing, I guess before I kick off, I'll say all of us are pretty public. All of us are on Twitter. All of us are around. So like definitely happy to do follow-up questions afterwards if we can't end up answering it here. So, but I'll kick it off pretty quick because we got a lot of material to cover. So I just want to dig in we kind of tackled ahead of time. There are 3 main, kind of themes that we're going to focus on during this release and then also in this presentation. So the first is there's just a ton of improvement to the admin experience in OCP. Obviously with the CoreOS acquisition, they were very heavily focused on that. And so there's a lot of exciting, pieces of that work coming into OpenShift with 3.11. So you're really seeing kind of the first drops of like really the merger of 2 teams that are really awesome. So the second thing is the operator framework, which is another exciting piece that really came from the CoreOS team, and then kind of a merger with some of the Ansible playbook bundle stuff. And so we're going to dig deeply into that a bit and explain kind of what's going on with that and kind of dig in how you can use Ansible and the operators together to solve essentially a bunch of different types of problems that you end up having when you run a distributed container platform at scale. And then finally, another one is around the metrics and alerts. We've done a lot of investment around Prometheus and Grafana, and so we'll dig deep into that a bit. So thanks. We'll go to the next one. So this is kind of the overall stack. I mean, probably if you've attended any of these, you've seen these before, but like in a nutshell, OpenShift is kind of split into 3 different layers, and even that's kind of how we mirror our sprint teams and everything internally. So we focus on kind of the service layer, the platform layer, and then kind of the I call it the engine room. That's where I'm at. I'm in the red box. So and you'll see we'll kind of break down the presentation as we go through it by kind of green, blue, red. So you'll kind of get an under.
I think you just muted Scott.
Scott, we lost your sound.
Oh, you lost my sound?
Did we lose Scott? I lost audio. Okay.
Yep. Can you hear me now?
Yes.
Okay, so I think it was maybe just an intermittent thing. Yeah, it looks like audio's on. Right. I'm going to kick it back to Rob then.
All right.
All right. Hi, everybody. I'm Rob Sumsky, the PM for the OpenShift console, and I came over from the CoreOS team. We've got a really great set of features in our new cluster console. This is kind of heavily focused on that persona of infrastructure admins and any shared IT team that is working on the cluster. And it really exposes a lot of the kind of CAS, containers as a service level features. So you get full visibility into all of the Kubernetes objects that you might not have been able to see before as more of a developer persona in OpenShift. It's using the same cluster authentication, so you can get to both of these consoles with your same level of credentials, and the navigation is dynamic such that if you have limited access via like an RBAC role, you'll only be manipulated.
That was all that rigmarole. I can't figure anything. I think we're just going to try to call into the phone here then.
All right. Next, please.
All right. Those.
So the admin experience is really cool into seeing your nodes. These are the things that are running your cluster. You need to be able to troubleshoot them, manage them, see what's going on resource-wise. So we've got a really great set of screens that can view the status of your nodes, and this is all of the Kubernetes statuses that are for like disk pressure and PID pressure and that type of stuff. You can all see via this new admin console. We've got a default set of metrics, as you heard about in the themes for this release, and those are accessible many different object types, nodes and pods, table sets, and all that good stuff. Anything that's running things, and that uses the Prometheus stack under the hood, and anybody with the cluster reader role above. Next slide. As I mentioned before, getting that containers as a service experience, as well as projects and namespaces. So as I was saying, we got a number of different views into some of the more kind of closer to the Kubernetes layer of objects in the cluster. So check that out in OpenShift 3.11. Next slide. I mentioned RBAC on the previous screen. This is really, really critical to doing proper security and access to the cluster itself. There are a bunch of really great screens for looking at these RBAC roles in a visual manner. Looking at these in the YAML view is really great, but it can be pretty hard to visualize. And if you want to see exactly what a role that you're granting to somebody is going to do, you can use these screens to do that. You can see the verbs that it can mutate different types of object levels, objects, and then you can even impersonate these roles via the console. So if you want to see exactly what access somebody's going to have, you can go impersonate that user, go click around the screen, see what they can add, edit, delete, that type of thing. And the beauty of this is all self-service. So if you have a owner of a project, like a dev lead on a team, they can manipulate their own service accounts and roles and role bindings for that namespace. Next. Also included is a cluster-wide event stream, and this is critical for seeing what's going on across the cluster if you're doing some maintenance or you want to see exactly what's happening. Team is complaining about some connectivity or something like that. So if you are a cluster admin, this is available across all namespaces, so you can see, the fire hose of what's going on in the cluster, as well as if you're an owner of a project, you can see that for just your project. You can also scope this down by certain types if you want to look at node events or just errors, just info, that type of thing. And this is a really great way to get a high-level view of what's going on if you got paged. Next. So that's a lot about the UI. Let's switch gears and talk about some of the operators. That was another one of the big themes that we talked about at the top of the hour. So we're happy to have the operator SDK available. And this is a way of building these smart application managers that are, Kubernetes native. So you're embedding a bunch of unique operational knowledge into a piece of software. And then, adding that logic, everything that would be in a run book, something that you would have in a wiki, anything that needs to be done to launch this application in this specific order and then change this config and then reload this thing, all that data can be added into an operator, and then you can really automate your application deployment. We have an SDK that helps you, kind of do a bunch of code generation so that you're not having to write 90% of the code. You're just bringing the business logic of whatever you're going to use. And this operator SDK has been used by a lot of our partners, such as Couchbase, MongoDB, Redis. And you can see a theme there. It's all about more complex stateful workloads need special management on Kubernetes. You can't just kill these pods and reschedule them. You might need to do data rebalancing. When you scale it out, you might want to scale out one component before the other, or scale it in a certain way. All that is embedded in an operator that you can use. We've got the SDK available, as well as other features in 3.11 around operator. Talk about next. So there's a number of flavors of operators that you can build. We have our Golang one, which is the the most complex. You're using the full power of the Go programming language and all of the Kubernetes libraries. But if you have a Helm chart, you can actually just get started with that. So the beauty about this is it's a more secure way to run Helm. So it's more automated. You're not running Tiller. And the way this works is you can take your chart and when you bake it into an operator, we actually call Helm internally as a library. And it's only scoped to the namespace where you're running. And then you can define a Kubernetes CRD. This is a custom object. So in the example on the right, we have this Tomcat object. If you want to model a new type, just like a stateful set or a deployment, you actually have now a new kind called Tomcat. And you can expose the values that you would pass into that chart as the spec of the object. So this allows people to reuse a chart many times and change configuration values about it. If you were moving something from staging to production and you needed to scale it up in production, you would overwrite the replica count, to be 20, for example. And whenever these objects are modified, the Helm chart will be applied. That's the power of the operator. So you're getting this live reconfiguration. Next. As I mentioned, we have the Go operator. This is the most complex. So using the same type of object example, a Tomcat object, you basically will model everything that needs to be done to launch, maintain, upgrade Tomcat, and put that into a logic tree in the operator, and it will instantiate that when a new Tomcat object shows up. It will scale it up, scale it down, change the max active sessions, for example, that you see here. To bake that into the config file, reload the container, whatever it needs to do. And this is really great for ISVs and development teams that have a lot of programming chops. If you are really comfortable writing Go and all the advanced features that you can do inside of Kubernetes and orchestrate that, you're going to be a really good fit for this style of an operator. Next. So once you've built your operators, you need to hand it off and run it on a cluster, or more likely a set of clusters. So we have in Tech Preview in 3.11 is the Operator Lifecycle Manager. Now this is the place for you to do rolling updates and deployments of a number of operators. Say you're running 1,000 operators on a cluster. As you have a number of teams, they can have access control to use certain types of operators. So if you've got a team that you want to be able to use MongoDB, you can install that operator on the cluster and make it available into their project. And then they can do self-service of that MongoDB operator and all the instances that it's running. And you can use this via their OpenShift Ansible installer, can get you easily up and running on this. And as you can see, our new admin console has a number of screens for manipulating these operators, as well as a catalog of some curated operators that we've been working on with some of our partners, which is a really easy way to get started. Next. Here's a view of those partners. So some of the folks that I mentioned earlier, Couchbase, Dynatrace, MongoDB, building on some infrastructure building blocks, as well as some offerings from Red Hat, our AMQ Streams, which is a Kafka product, as well as etcd and Prometheus, which are very, very popular operators that have been out in the Kubernetes community for a long time. If you make your own operators with the operator SDK, either the Go or the Helm flavors, you can add those into this catalog as well. And so this is the one-stop shop where all of your engineers can come to see what operators they can use. And so if they want to stand up a quick Prometheus cluster to support monitoring of their application, they can easily do that through. Next. We've got some work being done with our automation broker to integrate more heavily with Ansible Galaxy, so you get a lot more of the content that's being pushed by the Ansible community, and this is really great. So you can read it here, some about how you configure that with your OpenShift cluster, and those items will be populated inside of the service catalog. Next. Here's some more information about some of the ongoing work in the automation broker. Support for authenticated registries. We recently moved over to a new registry for Red Hat containers, registry.redhat.io, which has some authentication in front of it. So you can define those in the broker so that it can pull all those images that you want to have access to. Also really great is access control applied to the service catalog so that specific APBs can only be exposed to certain namespaces. This is very similar to what we just talked about with the operators, where you want to possibly limit certain teams to only have access to certain resources. So following the RBAC model of the rest of Kubernetes, you can also expose your APBs at the same level. So this could be limiting those to specific ones you want to be used in dev versus production. Next. Got a number of improvements to the builds that are builder features that are built into OpenShift and Jenkins. So plugin stability improvements is always great. Keeping up with the releases of Jenkins themselves, and a few other things to help you set your change triggers and decide how that is actually going to trigger downstream builds and that type of thing. Next. A number of different tools to help you do local development. We've got our container development kit has gotten some bumps, and it's based now on a newer version of Minishift. You can see a little bit more about Minishift 1.2.4 there. Really great way to use OCP locally and then ship that off to the same OCP version that you're running in the cloud or on your production cluster. And now we've got some OC and kubectl included in that as well. Next. All right, I think I'm handing this off. Thank y'all.
Yeah, so this is Scott McCarty. I kicked it off. I'm covering actually for Dirk Herman, who's a product manager for this. But with the internal registry, there's been some updates to it that are pretty important. The V2 catalog endpoints. So I don't know how many of you remember, but like historically there, in the V1, there was a search capability. In OCI V2, there's really like an ability to like list all of the images that are in it, and it's essentially a way to like enumerate all of the container images or repositories, if you want to call them that are in a registry server. And this is used by a lot of our partners. It's also used if you're programmatically hitting the API and doing things. So we've updated that to support that v2.2 spec, I believe. Another interesting feature that's been added is the ability to bulk mirror image tags. So like, or image streams, I should say. So image streams, like you can basically mirror them between different, OpenShift instances. And so that makes it really nice if you've kind of, everybody talks about pets and cattle in the context of cloud, but at the end of the day, there's also some pets. There's always some pets. And if you've built a curated set of images in one OpenShift and you want to essentially mirror them over to another, this is a really nice feature. Another couple thing, we've essentially integrated some, like I think Rob mentioned before, curated sets of metrics essentially in the registry that we now expose to Prometheus, so it makes it easier to monitor what's happening inside of the container registry in OpenShift. We've also kind of fine-tuned the debugging levels, and then finally a couple really important announcements. One, deprecating a couple things around the standalone registry installer. So you could work around it and do a single node install if you still really want that, but we're really kind of moving away from the standalone registry installer. That's more replaced now by the Quay enterprise offering. Another thing is we're moving away from registry console, so the cockpit interface that we had to that registry that was built into OpenShift. And then finally, the OCADM registry commands are going away. We're actually moving to an operator model. We're using an operator to manage the registry inside of OpenShift, which is actually really nice. Finally, we're looking to move to like a Quay core specification. So there's Quay Enterprise, which is a product that you would purchase if you want like an enterprise registry in your environment. But down the road, we're still targeting kind of second half 2019 to integrate a sort of a subset of those sets of features within OpenShift. So essentially, in a nutshell, replacing the distribution. Distribution is the upstream project that we use for the registry in OpenShift now, but moving to a Quay as essentially the technology that will be inside of OpenShift. And then also, I don't think I mentioned, but I think it's on here to we also have a target to open source the Quay enterprise code. So that's another thing that's on there. So moving to Quay v3 is coming out along with Claire v3. I did mention it's an OCI 2.2 spec, which is good. I think the biggest thing for this is it's really able to support multi-arc, and that includes things like Windows images. So now it's really nice because you can have a single enterprise registry server that has, whether you have ARM images and Windows images and Linux x86 images, you're good to go. Also a little bit of rebranding, and then also moving Quay to a rel-based image, which is kind of nice. So now we have a single supply chain for that, for running it as a container image. Then with Claire, we're essentially adding some new data models that you can import. So, I mean, in a nutshell, the value of this is that you'll be able to pull in things like, historically, Red Hat's always released really good oval data. And if you're not familiar with that, it's a stream of data that we publish that essentially maps like RPM packages to CVEs. So if you're looking for possible exploits that people could make to your software, you basically would say, okay, let me check this oval feed and verify that Red Hat's patched certain things. Also, the container programming languages have some of these. So, for example, like Java publishes their own format of essentially data stream that maps whether certain CVEs have been fixed in certain versions. And so we're basically adding the capability to basically look at these and consume these different feeds and start to like analyze programming languages inside of your container image. So, for example, if you had Java in your container image. And then another just quick little blib is around we are moving to like a Helm chart initially for Claire, so that it will be actually deployed. Currently, it was a little bit manual to deploy Claire with Quay as a sub tool within Quay, and so now we're basically making it more and more automated. Eventually, moving to an operator. And so with that, I'm going to move down into the platform, and you'll see the corner goes into blue, and I believe we're going to hand this to, is it Mark? I think you're going to cover that.
Yes, that's correct. Thanks, Scott. In this first one here, what we're doing with AWS Autoscale groups is we're enhancing our current capability of autoscaling Kubernetes clusters for increased workload elasticity. So it's a new feature that enables autoscaling nodes on AWS infrastructure on demand and based upon a predefined autoscale group. So every few seconds, the autoscaler checks to see what the pending node allocation is for pods, and then makes sure that enough nodes or AWS instances in this case are available to meet your desired capacity. So when demand drops and fewer nodes are required, the autoscaler automatically removes those unused nodes. And so with this optimization, you end up only using those allocated resources which are needed for the current demand. And so customers can realize savings here by only keeping active those instances which are required. To enable the feature, there's a few manual steps that must be executed outside of OpenShift. Those steps are highlighted here, and they're described in more detail in our product documentation. Next slide, please. Support for Ansible 2.6. So based on customer demand, we have support for a newer version of Ansible that can be used for both installations going forward, as well as upgrades from prior versions of OpenShift to 3.11. To use this update, it's basically a one-liner to enable the correct repo as shown in the example on this slide. Next slide, please. Another enhancement, customer installs are logged. So new for OpenShift 3.11, Ansible installs are now logged by default, and they're logged to a location that's defined by a log path parameter in the Ansible config file. The only requirement is that when you run any playbooks, that you be in the OpenShift Ansible directory prior to doing so. Next slide, please. Reference architectures. So the OpenShift reference architectures are moved into our OpenShift product documentation. This process started back in 3.10, and the content continues to be enhanced and updated. In particular for 3.11, all the ref arcs are in the process of being updated to that version of OpenShift. And we normally start to deliver these updates approximately 4 to 6 weeks after our minor release, because the reference architectures are based upon that G8 version of OpenShift. Next slide, please. We've done a number of enhancements to our default router, HA proxy. So quite a bit of work has gone into it. The table shown here represents a high-level overview of those enhancements. Quickly, let me provide a little more background information about each. Our product documentation provides much more detail than is shown here, and so I'll refer you to that for more. But basically, HTTP2, at the moment, with our HA proxy version 1.8, It supports HTTP2 for front ends. And so what that means is that we can terminate those requests at the router, and the traffic then needs to be translated to HTTP1 to talk to services within the cluster. On the performance front, you can now increase the number of threads for HA proxy so that your deployments can serve more routes, for example. So this ends up resulting in better overall performance for our research than increasing the number of cores. Dynamic changes. In our latest HA Proxy 1.8 version, there are more options for improved handling of our configuration changes. So the goal here is to minimize the impact and the need for having to do a full router reload whenever routes or endpoints change. Client SSL TLS cert validation. We've enabled mutual TLS authentication and also support for customizations, because our customers have told us that it's sometimes necessary to use edge or re-encrypt routes to support older clients or services that don't yet support SNI, but however still require certificate verification. And the last one listed there, logs captured by aggregated logging EFK. So customers want to be able to see traffic to their routes. So by deploying the router with an RSys log sidecar container, we can collect access logs so that operators can see them in the aggregated logging stack. Next slide, please. Since OpenShift 3.10, we've had the ability to assign egress source IP egress traffic from the cluster to come from a distinct source IP per project or namespace, so the customers can filter it on the edge. So what I'm going to cover here is a couple of enhancements. This slide and the next slide, a couple of enhancements to providing that namespace-wide egress IP. So what we've done in 3.10.1 and in 3.11 is we've added two options to make that egress source IP highly available. So how does it work? In this first method, basically a list of two or more egress IPs are defined for the project, each of which is assigned to a different host in the cluster. The first listed egress source IP in the array is then used for all of that project's egress traffic. And if for some reason that IP becomes available, for example, if the node hosting it goes down, then the next listed egress IP in the array takes over, and all egress traffic is then sourced through it. And if and when the original node IP comes back, the traffic is switched back to that original IP to rebalance the egress traffic. Next slide, please. A potential downside to that previous slide is that if you had noticed, it requires more than one egress IP to be added to the whitelist of the external service, and IP addresses are often a valuable commodity in the data center. So for those installations where that would be an issue, we offer a second option for making a project's egress IP highly available. With this slide's option, projects are automatically allocated a single egress IP on a node in the cluster, through which all of its traffic flows, and that egress IP is automatically migrated from any failed node to a healthy node. So why wouldn't we just make this the only option? The potential downside to this option versus the previous slide is that it's potentially slower by a few seconds to enable this particular failover versus the previous slides. For some customers, that's important. Other customers, it's not. But you now have the option to choose. Next slide, please. Configurable VXLAN port. So for those of you that are using OpenShift on top of VMware with VMware's NSX SDN as part of the underlay networking, the port we use for VXLAN in OpenShift is now configurable. So OpenShift uses VXLAN to provide association of pods in a project, even if they happen to be located on different nodes. A significant number of our customers do run OpenShift on vSphere infrastructure with NSX. And as it turns out, in VMware version 6.2.3 and newer, VMware modified their VXLAN port used for their NSX managed infrastructure to the same port we've been using in OpenShift 4789. They did this to adhere to RFC 7348. And the problem is that change on their part resulted in a port conflict between our two products. So customers do have the option of modifying the VXLAN port in VMware to resolve the conflict, but often that either isn't possible or reasonable for whatever reason to do in their environment. So we also made the VXLAN port configurable in OpenShift to give customers choice in how they choose to resolve the issue. Next slide, please. Security context constraints. If you aren't familiar with security context constraints, they are simply constraints that allow administrators to control permissions for pods. In 3.11, there's a new option to prevent containers from gaining new privileges, and so they're listed here: allow privilege escalation and default allow privilege escalation. There's also a new control over which sysctl options can be defined in a pod spec. There's forbidden sysctls and allowed unsafe sysctls. So these two features in combination have the net effect of being able to group sysctl parameters into safe and unsafe categories. And it does that with proper namespacing and pod isolation to enable that ability to set safe sysctls for a pod. So what exactly is a safe sysctl? In a nutshell, it must not have any influence on any other pod in the node, must not allow harm to the node's health, must not allow the ability to gain CPU or memory resources outside of the resource limits of a pod. So that's basically in a nutshell. And those are listed down below in the student notes section of the slide, but that's what defines safe sysctl. All safe sysctls are enabled by default. All unsafe sysctls are disabled by default and must be allowed manually by the cluster admin on a per node basis if you want to change that. Pods with disabled unsafe sysctls will get scheduled, but they will fail to launch. Next slide, please. Identity and access management. So GitHub Enterprise is now an authentication or identity provider for OpenShift, using OAuth as the controlling mechanism that facilitates the token exchange between the two. Also, OpenShift has in tech preview support for the security support protocol interface to facilitate single sign-on with Windows. More information about both of these can be found at the listed links. Next slide, please. And Tushar, I believe this goes to you.
Yeah. Thanks, Mark. This is Tushar Katarki. I'm going to be covering monitoring and logging and storage over the next few slides. I'm product manager in the OpenShift team based out of the Massachusetts area, Boston area. We are very excited to actually introduce Prometheus, as a GA feature. I know we introduced it as tech preview a few releases ago, but that was paused a little bit because of the CoreOS acquisition, because they also had a Prometheus stack, which was much more robust. And so this represents the culmination of that integration. So what do we get basically? We are calling this the cluster monitoring. So as the name indicates, it is really capturing the metrics and monitoring the cluster itself. This includes things such as, you can see down here, things such as the state of the node itself using the node cluster, node operator, node exporter, the state of Kubernetes, metrics regarding Kubernetes itself using kube state metrics, etc. And then the Prometheus server collects the metrics and stores it, and the alert manager is what you use to manage the alerts. There is also a Prometheus operator, as was alluded to earlier, is what basically controls the entire stack, its update, upgrades, etc. The way the way it works is that the stack itself, which comprises of the operator, Grafana, Prometheus, Alert Manager, Node Exporter, and State Metrics, is installed by default in its own namespace, and then therefore operator can log into Grafana and start looking at some of the out-of-box dashboards that we ship. They can log into their and then I'll cover that in the next slide. The other thing that happens here is that just a moment. The one other thing that I wanted to cover here is that the monitoring operator, through the monitoring operator, you can control the way you can configure the you can customize the configuration of the stack itself by editing the Ansible inventory file. So that's a pattern that is fairly familiar with most people who use it to install OpenShift. So that shouldn't be any different. So next slide, please. So as I said earlier, there are basically three distinct UIs. The first one really is the Prometheus UI for querying and plotting any metrics, as you can see here. That's the first one here. Then you have the Alert Manager UI, where you can see the alerts as well as manage the life cycle of the alerts. And I think this is that slide, this is that graphic over here. And then finally, you have for more detailed queries of the metrics dashboards, you have Grafana, as you can see on this picture here. I think a couple of important things to remember here are that right now you cannot add your own alerting rules, or you cannot add your own dashboards. That is something that we are working on for a future release. But right now we ship some default alerts and default dashboards which we think are relevant, and that's the only ones that you get. The way alerting itself works is that you basically Prometheus manages the alerting rules. If an alert rule is met, then Prometheus fires that alert, and then Alert Manager just catches it, and then you can get subscribed to that through things such as PagerDuty, etc., or Slack. Those are the two integrations, and then you would be notified of that alert. Next slide, please. We are also similarly with the logging stack, we have been shipping the EFK stack, Elasticsearch, Fluentd, and Kibana for a number of releases now. But with this release, we have updated the versions of Elasticsearch and Kibana. Elasticsearch moves to 5, and Kibana moves to 5 from like Elasticsearch 2 and Kibana 4 respectively. So what this basically gives, Elasticsearch 5 comes with if I had to highlight one or two things, the major improvements for Elastic 5 has been about performance improvement and also better resource utilization. So that means that with the same amount of quote-unquote resources, CPU memory that you have where Elasticsearch runs, you might be able to get better performance, query performance, for example, or you could actually get some optimization in terms of the amount of resources needed. So that's really good. The second bullet item that you see there is that now with the 3.1 release, you can actually save Kibana dashboards and share it between users. So if you feel like if a user feels that they have created a dashboard that can be shared with others and can be used as a template or maybe as is, those are the things that can be accomplished we're starting 3.11. The third bullet item talks about we have added a number of robustness improvements to how Fluentd talks to Elasticsearch. So therefore, you would find that pipeline is much more robust and much more reliable than it has been previously. So these are kind of the continuous tech debt and performance improvements that you'll find in 3.11. And then finally, to accommodate some of that, we have also increased the amount of default memory that Fluentd uses on the nodes to 756. It should say MB. The B is missing there. Sorry about that. Then finally, this is just a visual on the right to show you one of the exciting features about Elasticsearch 5 itself, and Kibana 5, is something called Timeline, and that allows you to compare two time series metrics, two graphs, as you can see here on this slide, and this allows you to do some more better troubleshooting by comparing what happened. This is an example of that shows pod logs and compares it with Kubernetes event logs and compares why this pod, for example, has stopped logging something because the Kubernetes event logs might be indicative or suggestive as to why that happened. So it helps your troubleshooting skills. Next slide. Switching to storage, the OpenShift container storage, one of the exciting new things we've been adding a number of features, including to the storage console, the web console, the OpenShift web console. This feature is basically talking about PV expansion, which is the persistent volume expansion that can be accomplished using the web console. Today, if you need to increase the PV sizes, then you need to go and edit the YAML file itself and then request the new size, and then that will result in increase of the PV size. But then with this new feature capability in 3.11, you can do that through a graphical user workflow from our web console, as you can see here. But just a note, this works with OpenShift container storage, which is our cluster storage, which is available with OpenShift, but also it's available with select other storage backends that support online expansions. Next slide, please. An important feature that we introduced, we actually GA'd with 3.11 is the pod priority and preemption. What basically this allows you to do is right now pods do not have the concept of priority. So what this allows you to do is pods can have a priority, and then that indicates to Kubernetes and to OpenShift scheduler what the relative priority of this pod is with respect to others. So what that accomplishes is that a pod with a higher priority, when it gets to the scheduler for scheduling, if it is not scheduler because there's if it is not able to schedule because there's no capacity, then a lower priority pod is evicted, so it does two things. One is it affects the scheduling order of the pods itself, and then it affects the eviction order of the pod. So a pod with a lower priority gets evicted. And then one of the best practices here to remember from a security point of view is that this obviously becomes a little bit of a security hole if somebody decides to use very high priorities for their pods, thus causing denial of service. So our recommendation is to use the resource quota feature to set up a quota per user per priority level, so that the DOS, the denial of service, does not happen, or at least is mitigated. On the right, we show how to use this feature. As an admin, you create a priority class. A priority class then is basically arbitrary value, as you can see. The higher the value, the higher the priority. And then on the right, you can see that pods can pick that priority class. In this case, they picked a high priority class, and then the scheduler is going to respect that. And also, when it comes to eviction, that's the priority that's going to be used for the eviction order. Some of the best practices here are for the admin to create a global default priority class. Apart from creating priority classes by name, the default priority class is what a pod will get if the pod has not picked in the definition a priority class. Then finally, there's something to remember if you're upgrading into 3.11. Obviously, it was not there previously, so there's pre-existing pods don't inherit this priority class, so their priority will be effectively 0. So something to keep and plan for that. And then finally, remember that priority and preemption feature is enabled by default, but can be disabled. Either priority and preemption or preemption by itself can be disabled. Next slide, please. I talked about Prometheus earlier, so a quick a slide on what you can expect in terms of how to do size for Prometheus. So this just shows something that we have done in terms of a sizing guide. It shows the number of nodes you could have, the number of nodes, pods, it could have, and the storage growth you can expect per day or for over 15 days, and the amount of memory that you would need. So depending on that, you would edit the Ansible inventory file to actually set the storage capacity as it is shown here as based on this table. Now, obviously, this is just an example to give you a guidance, but individual results might vary. Just use it as a guidepost. Next slide, please.
All right, thanks, Tushar. So we're going to move down into the engine room, as I call it, and talk a little bit about some of the foundational technologies. Just a quick update, with the release of OpenShift 3.11, it is actually on RHEL 5, but RHEL 6 beta is out right now, and so you'll see that coming down the pipe. And then also just a kind of another notice, Atomic Host is really kind of in a deprecated state. And, obviously there's a future here where we essentially merge what we had acquired, Container Linux from CoreOS and Atomic Host from Red Hat, and kind of they merge into something called Red Hat CoreOS. The internals, inside of OpenShift 3.11 are essentially Docker 1.13. The available, container engines are essentially Docker 1.13, Cryo 1.11. And we got rid of having two different Docker packages because actually now we're back to just one because it's not moving as fast. So major changes. I mentioned, we're definitely investing a lot in Cryo and moving towards the default for 4.0. Dot release down the road, but definitely you're seeing it as it's GA'd in 3.11 and works very well, and in fact is live in OpenShift Online with 3.11. Actually, it was live in 3.10 and it's expanding in 3.11. A couple other things that just for some of the internals, eBPF kernel is enabled in 7.6. So you'll see that during the 3.11 lifecycle, which a lot of people get excited about because there's a lot of tools in the upstream community that leverage eBPF, and so a lot of people have been kind of saying, when are we going to have that in RHEL? We were able to backport that 3.10 kernel that's in RHEL 7.x, and so you'll be able to use a lot of those eBPF tools, which I think is kind of cool. Just a quick update on Cryo. Cryo is pegged to the Kubernetes release, so the foundational Kubernetes release in OpenShift 3.11 is Kubernetes 1.11, which I don't think we explicitly said, and so the Cryo version is 1.11. Basically, if you think about Cryo, it's just a bridge between the OCI image format and the CRI container runtime interface between Kubernetes, and so it's a very lean, stable, just purely focused on the release of Kubernetes, and so it will never become out of sync, and it essentially should never be able to break Kubernetes, and so that's really kind of the value of sticking with a 1.11 Cryo, and always synchronizing it with the Kubernetes release and the OpenShift release. With again in that 7.5 time frame, which is live in the OpenShift 3.11 time frame, we moved to build a 1.2. We moved to multi-stage builds, which I would say is probably the biggest excitement there. Also coming down the road, probably 1.3 in the 7.6 time frame, which will also be during 3.11, because again the RHEL version moves, while the OpenShift timeline also moves, and so you'll end up kind of getting some features during the 3.11 timeframe. But one of the exciting ones is rootless. We'll be able to do rootless builds probably in the 3.11 timeframe pretty well, and so that's a really exciting feature coming down the pipe. Another one is Podman is GAs during this life cycle in 3.11 probably, so during the 7.6 release, which is beta right now. So another exciting tool that provides basically a command line compatible, set of sub commands that are very familiar if you use Docker. It's very Docker-like syntax, Podman run, Podman images, Podman RM, all of those things. So you can basically replace the Docker command with Podman, and 99% of your stuff will work. It's not used inside of OpenShift, but really Podman and Builder are both used as tools that you will typically run outside of OpenShift in a single node use case, whether that's like a dev server that you're using to build and run test containers to then ship into OpenShift to then run them. Think of Podman and Builder as kind of the glue that glues the OpenShift environment to a bunch of other things that you're doing, whether it's CI/CD environments and things like that. And so Podman is extremely useful in that, and so it's kind of exciting that's GA. It is daemonless, so it really wires into, like, if you have existing build systems that are outside of OpenShift, this is a really nice tool that kind of comes in the OpenShift toolbox. And then finally, one last note on container native virtualization. It is developer preview. There is actually, I guess there's three major things I want to say about it. It is developer preview in 3.11. We are definitely looking for people if you have, if you have an interest, cnv-product-team at redhat.com. With that, though, I will say there's two major values of it that why you might want to check this out. One, you can bring existing virtual machines. So if you have a VM and you want to bake off a virtual machine image, and then you want to pull it in and make it look like as if it's a resource object within the Kubernetes world, you can do that. That's extremely useful because now you can have a single application definition that includes VMs and containers. So for example, if you have a database that just doesn't containerize well, say you don't want to have Kubernetes kill it and restart it 30 times, or you don't have an operator that works well with it, or even if it's proprietary software or old software that nobody is around anymore and doesn't really fully understand how it works, you can still bring it in as a VM, manage it, fire up instances of it along with your application. So you might have an app that's made up of 2 containers, 1 VM. You can define that in a Kubernetes YAML file. You can define that in a Helm chart. You can essentially use all of your deployment methodologies that you use in OpenShift, which is really exciting because now that deployment methodology spans both containers and VMs. So that's really the last slide. Oops, sorry, I didn't mean to bump out of that. But with that, I think we have just a couple. Oh, last little notice I forgot. I did want to overview just some deprecation notices. We did put this at the end. We just because we thought it would be useful. This will be in the recording. I won't go through all of these, but I at least want to leave it on the screen for a while so you can see. A couple exciting ones that I'd say is moving to core DNS. That's one I get asked about decently. Obviously, the Prometheus one is exciting. A lot of the Docker calls we're replacing with Builda and Podman. Again, some exciting stuff in there. But also, if you're concerned about any of these, feel free to reach out to any of us. We can answer questions. Happy to help with that.
Just to be clear, a notice of depreciation just means that it's a notice. It doesn't mean in 3.11 it's deprecated. Just there's always a question about that. Just wanted to clear that.
Very good point, Tushar. A lot of the time, in fact, I historically always misunderstood the word deprecate. The word deprecate means that it's frozen in place, right? Like at some future time, we will actually remove it. But essentially think of it as still supported, but not going to add new features, and then will eventually be removed. So deprecation is kind of in a frozen state towards the end, of something's life cycle, as opposed to removed right now. And then here's the final kind of roadmap that you look for going forward. Again, I'll leave it on the screen for a second, but we are really getting close to the time, so I don't have a lot of time to go through all these. But if you have any questions on anything, again, feel free to reach out to any one of us.